Hi guys, this is Alicia with Good Morning Sunshine. Today was day 9 of vet school, week 2, and I felt like I was gonna die. So today we didn't have to be there till 10 for lab. However, we were there all the way till 5. So lab was 2 hours from 10 to 12, and then I had to walk dogs on top of that because we each have a day we had to walk dogs too. So that took up more of my lunch. So first I didn't have snacks because we were in lab, and then my lunch was late, so and then I didn't get done with walking dogs because we had to walk them for 30 minutes. So I only had like a 20-minute lunch before our 4 hours of lecture. So that was fun. And we had the really fast guy that talks 70 miles per hour for 3 hours today. Yeah, he did 3 of our lectures today out of the 4. So it was fun. But anyways, today we did soft tissues of the neck and back. We did the appendicular skeleton, and then neurobio, third lecture. So let's begin. Alright, so I'm going to start with the soft tissues of the neck and back. I actually didn't finish doing my notes for this one, so you're going to have to bear with me a little bit. These are the ones I started last night, even before the lecture, and then he talked so fast that I couldn't finish them while he was talking, so it's been a great time. So we're going to start with cutaneous muscles, which are located within the superficial fascia. It moves the skin in response to like flies or other annoying stimuli, you know, when horses like move their skin. Or when dogs like shake, that moves their skin too. So we're gonna start there. So we have the platysma muscle. I'm gonna show all you guys these. I really wish I could turn the camera around. Somehow, Athena said I can do these videos on my laptop, which would make things a lot easier. But anyways. So here we have the platysma. It runs from the nuchal area to the angle of the mouth. It's in a dog and a pig. I also believe it's in a horse as well. But it's split into 2 parts. You have the cutaneous colli and the cutaneous fascia. So the cutaneous colli is down here, and then in this picture it's not showing, but the cutaneous fascia, it's basically says face in it, so it's that's the muscle that's on your like cheek and face. So yeah, it's our first muscle. Let's see, and then they gave us example of different animals too, so I can show you guys. Hey, it's me and Athena's song too. My Pandora loves me sometimes. So yeah, I'm gonna show you in a pig, and then I'll show you in a horse as well. So here's the pig example. Here we are. So we have the platysma right here. This is the whole platysma, and then it's broken into 2 parts, and then we have the cutaneous fascia. See, it's like the cheekbone right here on the face, and then we have the colli part, which is down here. And then we'll get to the other. I know there's different ones in here, but we'll get to those too. Okay. And then I'll show you the horse as well. So here's the horse, here's the cutaneous fascia, and then we have the cutaneous colli, which is number 2 right here. So it's a little bit different in a horse. The cutaneous colli is more developed and it's V-shaped. It arises from the manubrium. But yeah. So they're a little bit different in different animals, and we have to learn all the different animals, so that's fun too. So then we are going to the cutaneous trunci, which I'm going to show you in a horse right now. It's number 4. It's this big one right here. That's the cutaneous trunci. I'm going to go back and show you. Actually, I think I have it in my notes. Mine are a bit smaller though, but here it's the cutaneous trunci in the pig, and then in the dog it's the big one on the trunk of the body basically. And then we have the cutaneous omobrachialis. That's a big word. I'm going to show you on a horse here. So it's this long one right here coming off the leg. Oh, you guys can't even see. Sorry, it's the long one right here coming off the leg. I want to say I have it in my notes of the other animals too. So just give me a second. I just realized I have one labeled wrong, I think. Oh, no, I don't. Okay. I had to find it. Sorry, guys. Give me just a second. Maybe I didn't put it in here. Maybe I'm just kidding. I am just kidding. I didn't put it in here. But anyways, the cutaneous brachialis is the continuation of the cutaneous trunci, which makes sense because it runs into the trunci. And then we have the thoracolumbar fascia. I'll show you in the horse right now. So here's the horse. And then we have number 5. This is the thoracolumbar fascia. I want to say this was in the dog as well. No, it was in the pig. The pig had it. So here's my notes, and in the pig, it's that upper one right there, the white part. That's the thoracolumbar fascia. So then we got into the extrinsic muscles of the thoracic limb. This is where things got a little confusing. So intrinsic mean is you have one attachment on the limb, being the scapula and humerus, and the other attachment to another portion of the body. So that's what extrinsic means. Intrinsic is when it's one attachment and it attaches to the same limb. I think I told you that in one of my other sitcoms. So here we have the cephalicus, maybe, I don't know. I'll show you the word. But anyways, that extends between the brachium and the head, and I'll show you examples here. So those are my examples. It's right here. I don't know if you see the blue there. And then this is the muscle right here. I'm gonna have to learn how to say all these big words, guys. So the brachiocephalicus, there we go, brachiocephalicus. Ha! Anyways, it is subcutaneous. It crosses the shoulder joint and it crosses the cervical intervertebral joints as well. So we have that. We went a lot into the brachiocephalicus. That's gonna take me a while to get a hang of saying that. So the brachiocephalicus actually breaks into 2 parts as well. It breaks into the cleidocephalicus and the cleidobrachialis. I'll show you what those are too. So they showed us in a cat example. I think I skipped over it actually. So here's our cat example. But anyways, I'm going to show you my notes. So the cleidocephalicus is the next one on the cat right there. If you see in the light blues where I circled it. And the cleidobrachialis is more down towards the brachia. And then it's different. So it's different in the ox. So the brachiocephalicus, it has one of those, but here we go. In an ox, the cleidocephalicus again divides into two parts in an ox. One being the clito-occipitalis in an ox, and the other being the clitomastoid. So here we have the clito. I'm going to show you my notes again. So the one in the middle with the purple, just the one in the middle, that's the ox one. But anyways, the top one on there, that's the clitocephalicus. And then we have the clitomastoid. Also again, looking at the middle one, but this time it's the bottom one. So then it's also different in carnivores. So the clitocephalicus is divided again into two parts, but one being the cervical callus, I don't know. And then here we go. So we're looking at the middle one there, but the end one where it says carnivores, the top one's different. That's the cervicalis. So we have to know all the different names depending on the animal. So it's kind of hard there, but we'll get there. We'll get there, guys. Okay. So then we have the transversiaris. But anyways, it's between the wing of the atlas and the distal scapular spine. It passes deep to the clitocephalicus. Let's see. I think there's a bovine example for this, a dog example. So here we go. Let's see. Yeah, there's a lot of examples, and a horse example. So here we go. Here are all the examples, if you can see. So I don't know if you see the blue outline here, but that is the transversiaris here. In bovine, just cows. And then let me show you the horse one. A better version is the skeleton right here. Right there. And we keep going. Then we have the trapezius, which is the dorsal midline. It is the spine of the scapula. Let me see, I think I put that way up here in my notes. They were kind of all over the place, so sorry about that, guys. But anyways, I'm going to show you on my notes because you can better see it on the dog here. So it's the blue outline right here, number 5. That is the trapezius muscle. Then we have the rhomboides, I don't know, rhomboides, that sounds better actually, which lies under the trapezius and is the dorsal midline of the neck and craniothorax. It inserts on the medial dorsal border of the scapula. So I'm going to show you here. So here's that muscle. Hopefully we actually get to see muscles, because I learned better like looking at them too. But then we have the latissimus dorsi. Latissimus, I think. It's a very broad muscle running from the thoracolumbar fascia to the teres major tuberosity of the humerus. So this one's kind of easier to see here. That's a big old muscle. It's used to flex the shoulder joint. And then we have the serratus ventralis. It is fan-shaped. It's running from the transverse processes of the cervical vertebrae and ribs of the cranial half of the thorax to insert on the serrated face of the scapula. So that's where the serratus comes in. Let me see. And it supports the weight of the trunk. So here's the example of that. It's those muscles right there. Oh, here's a better picture. Here's the actual muscles of a horse here. And then these ones right here are the serratus ventralis. Serratus ventralis. And then we got into the pectorals. So we have superficial pectorals. It is subcutaneous. Let me see. But it's broken into two parts. It has the cranial descending part, and then it has the caudal transverse part. So let me see if I can show you here. So I know there's two on here, but the top one being the cranial part, because it's more cranial towards the head, and then the caudal one is the bottom one here. So then we have the descending pectoral. This was kind of hard to see. I haven't made a flashcard for this one yet because I was trying to understand it. So I'm not even going to go over that one because I don't understand that one myself either. But I guess it shows it on here. Here's a descending pectoral. It's the bottom one right here. That's a descending pectoral. So I guess I could put that on my slide now because I know where it's at. But then we have deep ascending pectoral. Is the cranial part is covered by the superficial pectoral, but is subcutaneous over most of it. It attaches from the sternum to the humerus. Let me see if I can show you here. So there's two examples, one in the dog, it's the 9, the one at the bottom. And then right here. Both being deep ascending pectorals. I can now make one for the descending ones since I know where they're at. That's exciting, actually. So then we have the subclavius. I don't think I made a flashcard. Yeah. So all these are new, and I haven't made flashcards for the rest of these, but I'm going to try to go over them with you guys. So we have the subclavius, which is cranial deep pectoral muscle. Let me see if I can show you here. It's number 2. Here's the examples of it right here, or you can see it right here in the horse example. And then here's also a horse example. It's this one. So then we went muscles in relation to the vertebral column, the epaxial and hypaxial muscles. And there's a lot of these, and I, again, haven't made flashcards for most of these, or any of these, actually. So we have the cervical hypaxial muscles. We have the longus colli, and then we have the longus capitis. The longus colli, I guess, breaks into 2 parts. You have the cervical part and the thoracic part. So one here. This is kind of a weird diagram, but here we are. So one right here, that's the longus colli, and then 2 in the back, that's the longus capitis muscles. Here's a better picture of the longus capitis. That makes it easier for you guys. It's the red one. Going all the way down there. So it's from the cervical transverse process to the skull. Then we have the lumbar hypaxial muscles. So I can show you those. Let's see. It looks like we have the quadratus lumborum. There's actually a lot of these. So maybe I won't go all into those because I don't know those yet. We have the iliocostalis system. It's from the ilium to the ribs, ends at C7. But here's the iliocostalis, here to here. There's the lumborium, and there's the thoracis. These are all big words, huh? Then we have the longissimus system. That's a lot of S's. It's running between the ilium and the wing of the atlas. The atlas being the first bone, C1. And ilium, of course, being one of the pelvic bones. So here's the longissimus system. It's very big. So there's the lumborum, the thoracic, the cervicis, the atlantis, which is where, and the capitis. Includes all of those. Oh, and I guess the intertransversary muscles include the serapis, the thoracis, the lumborium. So I guess it is divided into two parts too. And then we have the transversospinalis system. It's the most medial. It is attached to the bodies and the DSPs of the vertebrae. We have the multifidus. And then the semispinalis capitis. So I'm really not going to go into these because I haven't studied them myself and I don't really want to give you wrong information on them. So we will talk about those another time, okay guys? And then we got into additional muscles of the neck. We have the splenius, which is the large triangular flat muscle. It lies dorsolateral on the neck. Let me see if I can show this to you here. Here's the neck. And this one right here, that's the splenius. I keep touching it and my computer doesn't like to be touched. And then we have the sternocephalicus. It's from the manubrium of the sternum. So let's see. Here we go. The sternocephalicus muscle. It's this big long muscle right here. Then we have the sternohyoideus. That's fun. So this is from the manubrium to the basi hyoid bone. Let's see if I can show you here. So it's this one right here. I don't know if you guys can see that. Probably not. I'm trying to show you this one right here without my finger getting in the way. So another muscle of the neck. And then we have the sternothyroideus, which I'm going to show you the same picture, but it's from the manubrium to the lateral surface of the larynx. So it's this one on this side. And that's all he got to, which is surprising because he's usually pretty fast. We didn't get to the last few slides, so at least I don't have to make flashcards yet for those. So from there, we went to the bones of the appendicular skeleton. He actually started with that lecture, but he was supposed to start with the muscles of the neck. So we're going to get into the bones of the appendicular skeleton. This was 80 slides long. So he didn't finish the other one because he wanted to finish this one. So again, what does appendicular skeleton mean? I told you in the last sitcom. Well, anyways, it's the limbs, so the forelimbs and hind limbs. Everything else is part of the axial skeleton. He had a lot of, I had to go through his first slides. There was a lot of them. So then we got into long bones. So I also talked about this in, I think, yesterday's sitcom, where we have the epiphysis, the diaphysis, and the metaphysis. I went over this yesterday, but anyways, I'm gonna give you a lecture on it because we learned it today as well. So the bones at the end, think of dog bone, maybe the round parts of the top. Those are the epiphysis. The trunk is the diaphysis, and near the end by the epiphysis is the metaphysis. So at least I know what those mean. So I knew that going in, so that's fun. So we have the proximal epiphysis, and then we have the distal, which is at the bottom. And then we also have the proximal metaphysis and the distal metaphysis. So there's one on each end by the epiphysis. And then the physis is epiphyseal cartilage. It is a plate of growing cartilage, so like a growth plate. So here's a whole diagram explaining all of this, what I just told you, so it makes more sense. So then we also looked at it on x-ray, so I can show you here as well. So we have the diaphysis up here, the metaphysis, and then the physis is that line because it became fused together right there, and then we have the epiphysis at the bottom here. So that's what we look for on x-ray, normal x-ray. So then we got into the thoracic limb and pelvic limb. So the thoracic limb is used for support, whereas the pelvic limb is used for propulsion. The thoracic girdle includes the clavicle remnant and the scapula. The pelvic girdle includes the ossa coxarum and the sacrum, and the first coxagile. That's not how you say it, but we're going with it. Vertebrae. There's no bony articulation with the axial skeleton for the thoracic limb, but there is a connection with the axial skeleton for the pelvic limb. Our flat bone for the thoracic limb is the scapula. The flat bone for the pelvic limb is the os coxae. And then the long bones of the thoracic limb are the humerus, radius, and ulna, whereas the pelvic limb's long bones are the femur, tibia, and fibula. Keep me inside a pocket of the red jeans. And then for the feet, on the thoracic limb, we're talking about the manus, whereas the pelvic limb, we're talking about the pes. So on a horse, he actually showed us a big diagram here of all the parts. I'm not gonna read them out to you, but here's the shoulder joint, the elbow joint, the carpus, and then all these little ones here. Hey! Shush! Hold on, I have to let them out because apparently I think mom's home and they get mad when they're not with grandma, so give me just a minute. Because if not, they're gonna bark the whole time and that's not gonna be cool. Okay, so then we got into the major features of the thoracic limb bones. So we have the scapular region, we have the brachial region, the antebrachial region, and the manus. So the scapular region, of course, includes the scapula. The brachium has the humerus, The antebrachium has the radius and ulna, and the manus consists of the carpal, the metacarpal, and the phalangeal regions. So we're going to talk about the scapula of a dog first. So here we have the scapular spine, the acromion, the glenoid cavity, the supraglenoid tubercle, the serrated face, and the subscapular fossa. I'm going to show you all these real quick too. If you can see this. So let's start with number 1. That's the scapular spine. Of course, that's what it looks like. Number 2 at the bottom is the acromion. Then we have number 3 here, which is the glenoid cavities. As you can tell, they're cavities. Then we have the supraglenoid tubercle, which is number 4 here, the sticky out points. And then number 5 being the serrated face. And number 6 being the subscapular fossa. Hopefully you guys can see that too. So then we have the cat acromion. It's complex and has 2 processes. It has the hamate process and the suprahamate process. So I'll show you this. This is where it differs in a cat. So one right here being the hamate process, and the suprahamate process is that big sticky out point right there. So the acromion's in 2 parts, not just one, compared to the dog. So the clavicle, we got into that a little bit, is present in a cat, but can be mistaken for a bone in the esophagus on a lateral radiograph. In a dog, though, it's represented by a fibrous clavicular, there we go, intersection in the brachiocephalicus muscle. So then we got into the humerus. He was talking about how spelling counts. We don't want to mistake the humerus for humerus. You thought that was funny. Or the ilium versus ilium. So there's 2 iliums in the body. Ilium is also a pelvic joint, but the other ilium has to do with something in the intestines, I believe. And then, not to confuse brachial and bronchial. And then biceps. What biceps are you talking about? You have to be clear there, because you have biceps on your arms, but you also have biceps on your legs. So then, again, starting with humerus, we have the proximal extremity, the body, the shaft, and the distal extremity. So here we are, proximal, the body, shaft, and the distal extremity. So starting with the proximal extremity, it has a head and a greater tubercle. So I'll show you here. So on this side, number 1 there, that's the head, the big round part right there. And then we have the greater tubercle, which on number 2 right here. That's a lateral view of the humerus. And then we have the shaft, of course. It has the deltoid tuberosity. So that's the deltoid tuberosity right there, and the shaft being the whole thing. And then we have the distal extremity. It forms the humeral condyle, which articulates with the radius and the ulna to form the elbow. So I'll show you this. It's at the bottom right here. That's the distal extremity, and it forms the humeral condyle. And with the distal extremity, it also has the supratrochlear foramen and the supracondylar foramen as well. So the supratrochlear foramen is in a dog, but then we have the supracondylar foramen in a cat. So then he showed us on x-ray too what it would look like. So here we have the greater tubercle back there, sorry. We have the supraglenoid tubercle, again what we talked about right there. And then we have the lesser tubercle down here. We have the subscapular notch up here. We have the coracoid process, the acrium, which we talked about earlier. We have the intraglenoid tubercle, which we also talked about back here. The glenoid cavity in the middle right there. And then we have the caudal aspect of the humeral head. I know that's a lot of information in one picture, but that's what we are going to do when we look at x-rays. So then we got into the radius, which is a flat rectangular bone. It is the main weight-bearing bone of the thoracic limb. It also has a proximal extremity, the shaft, and the distal extremity. So basically the same, just a different bone here. So we have the shaft, we have the proximal extremity, and the distal extremity. So starting with the proximal extremity, the head articulates with the humerus and the ulna, which creates the elbow joint. The distal extremity articulates with the carpal bones and the ulna in carnivores. So we have those. And then we have the head and the medial styloid process on the radius. So the head being up here, and then these are the medial styloid processes. And then we have the ulna, which is the longest bone in the body, but it bears no weight. It serves for muscle attachment and formation of the elbow and the carpal joints. Also, it has a proximal extremity, the shaft, and the distal extremity. But here's what the ulna looks like. So the proximal extremity, also called the oilocranium, which is the point of the elbow. The oilocranium is concave medially. It has the trochlear notch and the ancunal process. For the distal extremity though, it forms the styloid process of the ulna. So I'm trying to show you here. So here's the ulna. Down here we have the styloid process. Up here we have the oilocranium tubercle. We have the ancunal process, which is this one sticking out right there. The oilocranium being this whole big thing right here. And then the trochlear notch right here. And then we have the radial notch right there. It's a small, small bone. It's a lot of things on the ulna. So then we got into the manus, the forepaw. The manus is the distal part of the thoracic limb. It consists again of the carpus, the metacarpus, and the phalanges. The carpus has 7 small bones arranged in 2 rows, proximal and distal. The proximal row has 3, including the radial, the ulnar, and the accessory. The accessory carpal bone is located palmar and lateral, and is the only carpal bone having muscle attachment. The distal row are numbered from medial to lateral, 1, 2, 3, and 4. So I'm going to show you here. Let me see. Just the big picture. So again, 1 being here, short, 2, 3, 4, and 5. Up here we have the proximal carpal bones. This is the ulnar and the distal carpal bones. And then we have the metacarpal bones. And then we have we'll talk about phalanges in a minute, but we have proximal phalanges, middle phalanges, and distal phalanges. So the metacarpus has 5 metacarpal bones, numbered 1 through 5. We also again count from medial to lateral. The first metacarpus is the shortest, like I said. And then we have the phalanges. Which are the fingers. You guys should know that, basically. Each digit has 3 phalanges, the proximal, middle, and distal, like I was saying. And then we got into sesamoid bones. Each digit has 3 sesamoid bones, 2 palmar and 1 dorsal, except the first digit only has 2. But anyways, the sesamoid bones, I'm going to show you here, are these bones right here. So then we got into major features of the pelvic limb bones. So the os coxae equals the hip bone. I'll show you. And we have 2 of those, so one on each side, but this is the os coxae. The bony pelvis. Each is formed of 4 bones. You have the ilium, like I talked about earlier, the ischium, the pubis, and the acetabulum. So the big one being the ilium, then we have the ischium, we have the pubis here, and the acetabulum. You know, matter what. I like this song too. So the acetabulum being the socket for the head of the femur. And then we have the pelvic symphysis, which is the joint between the right and left halves on the ventral midline. And then we have the obturator foramen, which is a large opening bounded by the pubis and ischium. Let's see if I can show you here. All right, so we have the pubis. And then we have the acetabulums, the holes. Let me see. I don't know. And then we have these. And I think those are their obtural foramen. Oh no, foramen means holes, so yeah. I'll have to get back to you on that one because I'm not really sure about that one either. And I also don't think I've made notes for that either. And I don't want to lead you in the wrong direction. I think I'm right on that one, but I could be wrong, so we're just not going to go into it. So then we got into ilium, being the most cranial bone. So it has a wing, and a body, and a shaft. So here, there's the body. Here's the wing right here, which make up the ilium itself. And then we have our auricular surface, which is the shaped surface for the articulation with the sacrum. Let's see if I can show you here. Can you see the arrows? But anyways, they're these right here. And then we have the ischium, which is the most caudal part of the hip bone. It forms the ischial tubercle, and it forms the caudal part of the pelvic symphysis. Let me show you here. Down here, here's the ischium. Right there. And then we have the pubis, which forms the cranial part of the pelvic floor. And it forms the cranial part of the pelvic symphysis as well. So the pubis is this right here. Then we got into the major features of the femur. It also has a proximal extremity, the body, and the distal extremity. I think you guys know what those are by now, but I'll show you the bone. There's the bone. So proximal again, distal, shaft. I'll probably stop going over that because you guys probably get the point. But anyways, so the proximal extremity on the femur has the head and the greater trochanter. So 1 being the head, and then 2, the smaller one, being the greater trochanter. And then we have the distal extremity, has the trochlea and condyles. So 2 views, same bone, but the condyles are these 2, and this convex there, how it dips in, is the trochlea. But again, major features of the femur, you have the head, the greater truncator, the trochlea, the medial condyle, and lateral condyle, like everything I just showed you. So then we got into the tibia. It also has a proximal extremity, the body shaft, and the distal extremity. Here's what the tibia looks like. So the proximal extremity has condyles as well, and it also includes the tibial tuberosity. So the tibial condyles being these 2 things, and then on the side here is the tibial tuberosity. And then we have the body, which includes the medial malleolus and the cochlea. These are kind of hard to differentiate between, or showing you on a computer is going to be mainly impossible. But the cochlea is the distal articular surface, and the medial malleolus is the non-articular prominence on the medial side. So then we got into the fibula, which also includes a proximal extremity, the body shaft, and the distal extremity. Here's what the fibula looks like. Also very skinny looking. So unlike the radius and ulna, the tibia and fibula run side by side and do not cross each other. So then last week we got into the pes, which is the hind paw. The pes region includes the tarsus and the metatarsus and the digits, the phalanges, and the associated sesamoids. So in yellow is the tarsus, and in blue is the metatarsus. The tarsus potentially has 7 bones in 3 rows. 2 proximal and 1 in the middle row, and then 4 in the distal row. The distal row is numbered medial to lateral, like we went over, and then the other bones are named. But when a bone is absent, the original number is retained. So then we went into the metatarsus, which is 4 bones. Again, numbered medial to lateral. And when a bone is absent as well, the original number is retained. And then there's 4 digits and associated sesamoids. So yeah, that was the last of the appendicular skeleton. And then real fast, I have last 10 minutes. we went into the third part of neurobio. So changing things here. So what is the general anatomy of a spinal cord segment? Here we are. I'm going to show you mine because this is stuff he forgot to go over yesterday, so I had to fit it in today. So the dorsal rootlets are blue, which are up here. Hope you can see. The dorsal root is purple, right there, next to the dorsal rootlets. And then the ventral root is red, which is these right here. And then the ventral rootlets are orange, which are over here. And then the spinal nerve is in green over here. So the spinal nerve emerges from the intervertebral foramen between adjacent vertebrae. So this being a spinal cord segment, highlighted in green right there. So then we got into what is the major anatomical organization of the brain. Here we go. I tried to color code it, but the telencephalon is in yellow right here. We have the cerebellum in pinkish, purplish. And then we have the diencephalon in green. And then we have the midbrain in this lighter purple. We have the pons in the teal. And then the medulla in the orange right there. So the medulla and pons make up the hindbrain. The midbrain is also called the mesencephalon. Oh yeah, the hindbrain is also called the rhombencephalon. And then the diencephalon and the telencephalon form the forebrain, which is also called the prosencephalon. So many different names for different things. So I can also show you, let's see. So like the spinal cord, the brain contains gray and white matter. So we got into the discussion of gray and white matter again. So the gray matter mainly represents nuclei, and the brain white matter mainly represents tracts. The tracts can be brain to brain to cord, or cord to brain. And then we got into the general structure of a nerve. So here's a nerve right here. We have the epineurinum, the pennineurum, and the fascicle. So fascicles are surrounded by a membrane by the perineurium. Fascicles are then collected together into the nerve. The nerve is then surrounded by the epineurium or the epineurium sheath. So the axon goes to are bundled into fascicles, which are then surrounded by the perineural sheath, and then fascicles are bundled into a nerve, which then the nerve is surrounded by the epineurial sheath. And then we got into spinal versus cranial nerves. Spinal nerves carry sensory afferents that enter the cord dorsal horn and motor efferents that leave the cord ventral horn. But for cranial, they carry sensory efferents to and motor efferents from the brain. So I know that was really confusing, but in simpler words, the individual spinal nerves carry the central nervous system afferents and efferents, whereas the individual cranial nerves can carry central nervous system afferents or efferents, or both. So there's 12 pairs of nerves. The lowest number being most rostral, that's number 1, and the highest number being most caudal. So I can I'm gonna try and show you this. I know it's a big old picture, but here we go. So first, we have the olfactory. Second, we have the optic. Third, we have the ocular motor. I'm missing one because that's 4. Anyways, I am missing one. Anyways, 5 here, we have the trigleminal. 6, we have the abducens. 7, facial. 8 is the vestibular cochlear. 8, we have the dorsal pharyngeal. And then we have the vagus. And then we have the hypoglossal. And then we have the spinal accessory. Hopefully you guys can see all those. So where do axons of cranial nerves originate from, or synapse within? So the cranial nerve axons originate from or synapse in cranial nerve nuclei called the CNN. The CNN is mostly in the brainstem. The cranial nerve sensory afferents entering the brain, synapse in afferent CNN. The cranial nerve motor efferents leaving the brain originate from efferent CNN. So then lastly, I think we're on our last part here. We got into what is the general flow of information through the nervous system. So in general, in the central nervous system, sensory, processing, and response organization are progressively more complex in more rostral regions. The spinal cord and brainstem can respectively organize simple sensory motor reflexes. So here's like a diagram sort of for you guys to look at. So from the forebrain, it can go to the brainstem, to the spinal cord, or the other way around, we can go from the spinal cord to the brainstem to the forebrain. But anyways, we would mostly start at the spinal cord here. So the spinal nerve motor efferents to trunk and limb muscles. So peripheral nervous system here, and this is the efferent side, this is the afferent side. So this is from the skin, muscles, and joints. And then we go to the brainstem, which control the motor efferents, the cranial and the cranial sensory ones. And then we go to the forebrain, which are complex motor commands and complex sensory processing. So I'm still trying to get the hang of that, but for now I think that's good enough. I know I still haven't talked about musculoskeletal, but that's okay. We did have a lab this morning. We were just learning bones though of the axial skeleton, which I already taught you some. But yeah. Anyways, today was a very long day. I still have a lot to do, so I hope you guys all had a good day today. Also, I don't know if any of you have followed my weight loss journey, but I started a year ago. I'm almost at 13 months now on it, but I finally, because I told you guys last year in August that I would hit my goal weight in a year. So I think it's been 12 and 3/4 months. But I did hit my goal weight today, so that was exciting. I woke up to that, so that kind of made my day, but still have a long day ahead, long night ahead, because our first exam's on Tuesday. But I love you guys, and I thank you guys for watching.